And I'm just going to okay, so I hope you guys tried the assignment, because it's a good way, like I always say, it's a good way of preparing for the exam, because it's like it lets you know whether or not you're having problems with solving a problem. Okay, so okay, I gave you here a diagram that shows a slab that's got a thickness of 250 millimeters, and of course, it's a nice slab. And I'm telling you, start with the joist space at 400. Now, if the joists don't work at 400, you can always space them at 300. If they don't work at 300, you can always space them at 200. Because as far as formwork goes, as you saw when you go select the plywood, the spacing can go anywhere from 4 inches to 6 inches to 8 inches, 10 inches, whatever you need, okay? So if ever you're designing something, like you don't have to stick to the standard 300, 400, and 600 millimeter spacing, because it's a very temporary structure. And whatever you need, and you should, space the joist accordingly. Now I'm giving you here 400 in theory. If all of a sudden you can't find a 2x12 that will work at 400, you can definitely go to a smaller spacing, and that, of course, by reducing the spacing, you will be reducing the load on these joists, and eventually you'll find a spacing that a 2x12 would work if you ever had to do this. And here I'm telling you that the studs are spaced at every 600, and I do this purposely because I just want to show you that you can definitely either check to see if it's okay at 600, and if it's not okay, well, you can just modify the spacing and make sure you have the stud spacing at a certain spacing so that it can have the resistance of whatever is being transmitted from the slab to the studs. And of course, you need to know the height, because any compression member is greatly affected by the height. And the span here is about 2.4 meters, which is about an 8-foot span. It's not too bad. So there's a diagram. Now for figure 2, determine the thickness of the plywood. Okay, use coffee form plus plywood. The plywood will be placed perpendicular to the support, and the deflection is limited to L over 270. Now guys, as far as deflection goes, if there's not going to be an importance on the architectural appearance of your, of the formwork, L over 270 seems to be an acceptable deflection. Otherwise, if you think that the architect is going to want to have a nice unundulated surface, stick to L over 360. This way you'll be able to minimize the undulations or the deflections caused by your formwork. Provide the load that the plywood can support. Of course, what I'm saying here is that once you go to the table, tell me what it can actually support. Now, the walking load is 3.2 kPa. Now, this is a pretty good standard walking load that you would have when you're designing formwork. And like I said, if ever you're doing something residential where there's only going to be maybe 1 or 2 people on your formwork to place the concrete for a small balcony, you can go down to a walking load of 1 kPa. It would still be acceptable. And now determine the size of the joist and the bearing lengths using SPF number 1, number 2, because that's what joists usually come in. This is the most common grade that you'll find SPF in. And as far as the studs go, well, of course, I want you to use 2x4s, okay? And you have to determine whether they can support the load based on the spacing that you see there at 600 millimeters. If not, how do you modify the spacing? Well, once you know what the PR value, then you know that you can work backwards and determine what spacing you need to put your studs at so that the PF value is going to be less than your PR value. Blocking is provided at mid-height of the stud. So at least you know that you're going to be reducing the unbraced length of the weak axis of the stud. Now, load on the plywood. Now, like I said, when you're doing plywood, concrete is to be considered a live load. And the easiest way to calculate the pressure caused by the concrete, you simply take the unit weight of concrete, you multiply it by the slab thickness, and that will give you the pressure that the concrete is going to be imposing on your formwork. And therefore, you take 23.6 times 0.25, I got 5.9 kPa just for the concrete, and I said that the walking load was 3.2. Therefore, I have a total live load that my formwork should be designed for, which is 9.1 kPa. Now, once I have that, the tables, we'll go to the tables. You'll see that the tables, okay, Okay, so if you see that here, plywood must be continuous over, well, let me just annotate. Okay, so here you can see that plywood must be continuous over 3 supports or more. Okay, supports are supposed to be 38 millimeters wide or larger. The design pressure is a specified load. Okay, so you don't, when you come to this table, you take the specified load, you not factor them. Okay, not the factor load. Okay, a 1.5 live load was used to determine. So therefore, these are already taken into consideration that it'll have a factor of safety of 1.5. So if ever there happens to be a temporary overload when you're placing the concrete, it should account for that as you're doing it. Now, we said that it was L over 270 perpendicular to the supports, and this was the spacing of our stud, and therefore we know that even if we use 12.5 millimeters, which to me is half an inch plywood, it would be sufficient to control the deflection that I need and to support the load. And therefore, like I said, contractors are going to typically buy 19 millimeter plywood and use the plywood. Good plywood, guys, believe it or not, if the guy takes the trouble of oiling it, in other words, treating it and this and that, they can be reused up to 50 times. So that's why they'll buy the 19 millimeter, in other words, a 3/4 inch plywood, and use that to basically buy. But then, so if you know 12 is good, you definitely know that the 19 would be more than ample. So that's just to let you know that if he decides to use 3/8 inch plywood, which is 9.5, you tell him no. I think that's too thin. You should maybe consider using something thicker. So that's the only reason why I'm trying to let you know that what this table tells you is that if the guy decides to use something thicker, not a problem. If he wants to use something thinner, then it's a problem. So last viewed. So I got 15 kPa, which is greater than my 9.1. Fantastic. Now, as far as the joist design goes, well, now I've got some dead load. I have the weight of the joist and I have the weight of the plywood, so I have to take that into consideration. So therefore, the dead load for the plywood. Now, last week, like I said, I was being very generous. I used 0.1 and 0.2. Here, I'm trying to be a little bit more accurate. I went into my wood book and I found that for a 1/2 inch plywood is 0.6 kPa. And I took a joist space at every 300 and 400, and this is what the joist was. So therefore I ended up with 0.2. But if, like I said, if you use 0.10 and 0. So if you overestimate your dead loads, you're not doing yourself any harm in terms of your design. You're only being that much safer. But if you want to be a little bit more accurate, of course, you can go to the dead load tables and get values that are a little bit closer to reality. It's up to you. You remember, you're designing, you're going to be responsible for the design at the end of the day. It's up to you how you want to what degree of accuracy that you want to make it at. And of course, our live load is what we calculated for our plywood. Now, here I know that my live load, my dead load is definitely not 10 times greater than my live load. So I will simply calculate the factor load for load combination number 2, whereby I take 1.25 times my dead load, 1.5 times my live load. Of course, now I've got to factor my loads in order to design my joists. So I get a factor load of 13.9 kPa. And so once I have this, for deflection purposes, okay, I get my WF, okay, times my tributary width. And of course, I said that we're going to start with a spacing of 0.4 meters, and therefore WF is 5.56 kilonewtons per meter. And of course, for the deflection purposes, I take the live load unfactored of 9.1 times 0.4, and that's what I'm going to use to calculate my deflection criteria. In other words, the stiffness, the ESI requirement for my stud, or sorry, for my joist. Now I calculate my MF, and like I said, this is basically a joist problem, nothing more than that. VF, and of course my ESI. Since I've limited the deflection for the plywood to L over 270, I will use the same deflection criteria for the joist, because it makes no sense to have something that's, the stiffness of one member being higher than the other. So I'll have this one equate to this one and put everything in terms of the, I'm sorry, this is, this is wrong. This is for steel.
Sir?
Yes.
If I use 0.3 for dead load, it doesn't make a huge difference there, but would I still be wrong? Because I
No,
used
no. Like if you use 0.3, you'd be very right. You'd even be more right if it works. You understand?
okay,
Because what you're doing is you're actually overestimating what the dead load is. You understand?
right.
And what's
Okay.
good about that is that if the contractor decides to use 3/4 inch plywood instead of 1/2 inch plywood, in other words, 19 millimeters, you've already accounted for that in your design. Understand?
Oh, yeah.
So I think that's a smart thing to do. I'm just trying to show you that you can go to the two extremes. You can be like over generous, and plus the load is not that heavy,
No.
or you can be you can be a little bit more accurate. And like the only time, like, did it work at 0.3?
I had to. Hold on, let me check. Yeah, yeah, it did.
I know exactly. I don't think that exactly. And what I'm saying is that if you took into account the other factors that you were able to reduce your, your MF, you understand?
Mm-hmm.
Then you shouldn't have a problem. So I totally support your choice of using 0.3. You follow what I'm saying?
Yeah. Okay.
So
Thank you.
okay, so like I totally support that, and if it worked, all of it. I did it to both ways because I wanted to show you that you can slightly overestimate your loads, okay? Or if you want to be a little bit more accurate, you can actually go and get the values that you would find in those dead load tables. You understand?
Yeah. Thank you.
Okay, that's it. So now ESI required, like I said, this is just a typo here. So now I'm going to calculate the ESI required and end up getting 177 times 10 to the 9th Newton millimeter squared. Now, of course, I forgot what my MF value. Oh yeah, I'm not there yet because I'm going to be modifying. So here I'm going to take advantage of the fact that my KD is not 1 and my KH is not 1 because I'll be looking at the values of single members. And since I know I'm going to have at least 3 members not spaced more than 600 millimeters apart, I can take a value. I can take the KH for case number 1, which gives me a value of 1.1. And since formwork is considered a short-term load, in other words, after 7 days, in theory, the concrete is going to be supporting itself. It's not going to be permanently supported by my structure. And therefore, I can take the KD equal to 1.15. And therefore, I will take advantage of these two factors, which will help me reduce my MF value. And therefore, I can go find a slightly smaller MR value in the table. So like where it penalizes you. Now, if you don't do this, well, I mean, it's like it's not, you're going to be overestimating your formwork if you don't do it. But where KD is not 1, in other words, where KD is 0.65 and KS is not, you understand, where all the values are going to be less than 1, then you should take advantage. You should make sure that you modify them correctly, because the tables, you should go through that checklist and make sure the table that you do the right, you fix your values according to the right factors that will be affecting the resistance of your wood. Now, the same thing for VF, and of course for the ESI, this is only affected by the moisture content and the treatment factors, therefore that stays the same. I don't have to do anything there. And therefore now I have 3.16, 5.3, and 177. So when I go to the joist tables, the only thing I have to remember when I go to the joist tables is that I am definitely not here. And that's because even though I got joists and even though I have plywood over it, I don't have the right nailing requirement, and therefore I will never use these values for formwork. Okay. The only thing this stays the same regardless of whether it's a single member. So I never use this for formwork. I always use a single member because of the nailing requirements for case 2. And of course, I'm using SPF, number 1, number 2. So I see here that a 38 by 235 gives me 409. So Nicola, you probably had an MR value very, very close to what I got, right? Your MF value is very close to what we got?
Sorry.
Exactly.
Yeah, I got MF equals to 4.04.
Exactly. So therefore it would still work, right?
Yeah.
Okay. So that's good. This is good. And I need to be over 177. That's good. So therefore this, a 2x10, okay, a 2x10 will be providing all the 3 values I need for my design. So there you go. So I'm going to use an SPF number 38 by 140 single member, and I have an MR of 4.09. Okay, and you had 4.06 here.
Yeah.
Did you reduce your values by?
Uh, well, my MF was 4.04. Oh no, see, yeah, I reduced it and then I got 3.12. Sorry.
Okay, exactly. In other words,
Yeah.
you, because I found that to be a little bit on the high side, but because
Yeah, no, I looked at the original.
okay, exactly. So now MR is 4.09, the MF is 3.16, fantastic. The VF is good, and of course the stiffness. So this would give me a stiffness even well over L over 360, but I don't care. So there you go. So that there's my joist. And as far as the bearing lengths go, well, you know, if you remember, this is where you get the value of Q, the small value of QR. And again, the checklist, okay, if you want, you can take advantage of the fact that you have a low duration that is not standard. And if you want, it still applies. And the KD is 1.15, and therefore you can take that and calculate the bearing length. And so here we go. So therefore, I will take advantage of the fact that I have a short-term load, okay? And therefore, it will slightly reduce by 15% the LB required down to 36.2. And of course, if I'm building a wall here that's going to have a top plate here with my joists like this, okay? I know I'm going to have 89 here, and therefore, if the guy puts the joist all the way back there, well, I know the LB provided is definitely going to be more than 36, and therefore I have no problem. The only problem is that if the guy decides to all of a sudden sit very close to the edge of the wall, which I don't like because it's going to cause eccentricity for my studs and so on and so on. So I would tell him, no, I'm sorry, you're going to have to go through the whole back and make sure you're so it's not just for the LB. If the guy ever decides to put his stud right at the edge, don't just worry about LB here. Also worry about the eccentricity that it causes to your stud. That's even more important than DLB. Understand? So I would tell them, make sure that the thing is sitting all the way to the back of that wall that's supporting my formwork. Okay, so there is the LB required. So I know that if, as long as the guy who's building the formwork, the carpenter who's building the formwork, he puts his stud all the way to the back of the wall, I'm going to have 89, so it's ample, not a problem. Now, as far as the bearing wall goes, well, here we go. We have 38 by 89 at every 600. Now the length is 300, okay, and blocking at mid-height. So therefore the LD is going to be 3,000. The LB will be 1,500 because I'm blocking the B, okay. So therefore this was my factor load. That doesn't change for the wall. And of course the factor load times the tributary area gives me my PF. So therefore, half the span times the stud spacing is what I have. So if you guys, what you should always, like I do this, I write this down so you guys can, but it's better you guys actually see it than you actually worry about how this is done, you know. So here is my span here of, what was it, 2,400, okay. My joists are running this way and my wall is here. So it stands to reason that half the load will go there, half the load will go there. And of course, each stud will be supporting, okay, so if I can calculate the tributary width of each stud and the tributary width, and therefore this gives me my tributary area. That's the way you should really be seeing it. But if you're, you know, you should actually be visualizing it, and this is how you would write it out so that people could understand what you're doing. So now, so 2.4 divided by 2 is 0.6. I have it, so therefore 0.72 square meters for each stud. And of course, now my PF value is 10 kilonewtons. Now that I have to make sure to see if my PR will exceed 10 kilonewtons. And of course, it won't. But I did that purposely for, you know, so you guys can start developing a certain understanding. Now, here again, okay? we have, like I said, the LB is 3000 because nothing's supporting the D dimension, but we blocked the B dimension, so therefore the LB drops down to 1500. And therefore, by checking the slenderness, we determine which is the one that's going to govern. And of course, the higher slenderness is the one that governs. Here I have 33.7. Here I have 30. So therefore, it's the B that will govern in this case. And guys, be careful. This is the limit. Okay. So for example, if I would not put any blocking here, of course, this would be twice that value. In other words, I would end up with almost 70 here. And that should be a real big red flag that something is wrong. As soon as you exceed that 50, something is definitely wrong. Okay, so keep that in mind. That's why they give you these limits, because they're saying after that, it is so slender that it almost has absolutely no resistance. So keep this 50 in mind. And okay, so now I know that it's the B dimension that governs, not the D. Therefore, I'll calculate everything with regards to PRB and not PRD. And that's what's nice about checking the slenderness. So I'll use PRB. Now, phi FCAK. So phi FC, of course, what I'm going to do, this is where I get the value. But what I'm going to do when I go to the table is I'm going to, first of all, make sure I'm in the right species, make sure I'm in the right grade. But then I'm going to take the fact that I'm doing some form work here, so therefore I will take advantage of that and use a slightly higher value of phi FC. Okay, so if you were doing a floor, of course you use a standard. If you do something that has a permanent load on it, you can. So therefore I will take advantage of the fact that I am doing short term, and of course don't forget the units are in MPa. So that's where I will use for my phi FC value. So 9.91 MPa. Now the area, of course, the cross-sectional area 2x4 is 38 by 89. Okay. And now the size factor, and of course, again, you cannot exceed 1.3. That's the limit of the size factor. And therefore, now here again, I take the unbraced length with respect to the B dimension. I end up with a value of 1.52, which I do not use. Since I cannot exceed 1.3, the maximum size factor that I can have is 1.3, okay? And like I don't know if you guys remember this, but I said they found that if I take a 2x4, okay, and I take a 2x12, well, even if it's the same species, the same grade, and even if I cut it, the 2x4 from the same tree, they found that the smaller the member, the more resistance it had. And they worked it out by, they've been doing a lot of testing, and that's how they came up with this formula. Okay, so that's how they came up with that formula, and it's interesting that it's not in proportion. You understand? So you think that if everything's constant, it's just a question of like it's just the size that's going to different, but it's not only the size; it's also the smaller the size, the stronger it gets. That's pretty interesting when it comes to wood. So now, of course, this is the slenderness factor, not the slenderness ratio. The slenderness factor, of course, this is the equation. And like I said, when you're doing this equation, it cannot be more than one, okay? If you get something more than one, you've done something, you cannot have a slenderness factor that's going to give you a value more than what it actually is. So it doesn't make sense. So keep in mind that this KCD value has to be always less than 1. And the higher the slenderness value, the closer it's going to be to 1, to 0, I should say, okay? And the smallest, like for example, if I have a slenderness value of 1.0, it's going to be very close to 1. If I have a slenderness value close to 50, it's going to be close, it'll be very close to 0.1. So that's how you can get an appreciation of whether you're on the right track when you're doing this calculation. Now, in this formula, of course, I have to go get the ratio of FC over E prime. So I go to table 3.3 for that. And again, when I come to the table, I will take advantage of the fact that, well, the species, the grade, the first thing I worry about. And of course, I'm in untreated wood. And of course, in this case here, I will take the short term and I will use 59.1. And don't forget that this is divided by 1,000,000, okay? So now this is a ratio, so therefore there's no units. This is MPa, that's MPa, so it's unitless, it's just a ratio, 59.1. So that's where I get that value. Oops, I shouldn't have done that. Of course, now I'm going to get, okay. So I get 59.1. Sorry, I apologize. Okay. Now, after that, now in here, this is why, like it's important that you calculate this correctly because it gets used again here in this formula here. So therefore, if you make a mistake here, it's going to get carried over into this formula here. So be very careful about that. And so now, and of course, okay, so you take all of this. This you've calculated from the very beginning, the slenderness ratio. This is what determined which one governed. This was your slenderness ratio. And of course, your size factor, the ratio of FC over E prime, and of course, add it to 1, take the inverse, and hopefully, it will be less than 1. Like I said, 0.174. And if I say this seems very reasonable because my slenderness ratio is around 40, and that makes sense to me. And I'm pretty sure if we had a slenderness ratio around 50, and we would put it, if somebody put 50 in here, you'll see that you'll start getting very close to 0.1. And that tells me that, yeah, that makes sense. That seems to be a good value. And guys, just for, if ever you're doing this in real life, okay, do this calculation in your calculator, store it in the memory, and redo the calculation, and then subtract the memory. And if you get 0, go on. Always do your calculations twice. That I still do that to this day. Okay, I'm just letting you know that that's good practice, and it's very embarrassing when because if you make a mistake here, the mistake just gets carried all the way to the end of your final choices or your final design. So don't ever just do it once. And like in school, yeah, you lose a couple of marks here and there. Oh, I still got over 60, I passed. In real life, I can tell you, in real life, they don't look at the 99% of the projects you did correctly. They will always look at the 1% you did incorrectly, especially if it caused a problem. And they totally disregard the 99% that you did correctly. So keep that in mind. In real life, it's 100%, no less. Out of that, and even if it's 98% correct and 2% wrong, it's the 2% that counts. The other 98% gets totally disregarded. So in real life, and that's why I say life is good in school. It's very less stressful than in real life. So enjoy your time while you're in school. So now I've got all my values, and of course I put into the equation, and then of course here, this is an MPa. I have to convert this to kilonewton. Therefore, I basically divide by 1,000. And I see that my PR value is 6.97, which is no good. So not a problem. So instead of me making bigger studs, why don't I just put them closer together? Now, how much closer? Well, this is just, mathematics, okay? So basically, I know that the PF is a factor load times my tributary area. So all I got to do is basically adjust my tributary area. I can't play with this because that's the loads that I have to work with. The only thing I can actually, play with is my tributary area, and therefore I can't play with the span. Okay, I can, and then the only thing I can play with is the spacing of my studs to minimize the tributary area so that the PR value is going to be exceeding my PF value. So basically, the span stays the same. The stud spacing becomes a variable, and I just want to make sure that when I put it this equation, the PF value is less than 6.97. As long as it's less than 6.97, it will be correct. And I end up getting 0.4 meters. And of course, I can specify 0.4 meters, but why do that when you can specify 16 inches and therefore you'll space them at every 400? And if I put my spacing at 400, I will get a value of PF a little bit less than 0.97. And therefore I tell the carpenters, put the studs at every 16 inches on center. It should be okay as long as they put the blocking at mid-height to laterally support the stud. And see, if I put this in, I get 0.67. It's less than 0.97. Perfect. And therefore everything's good. Now, this is good to check. Guys, when you're doing formwork, keep in mind, whatever you're putting at the bottom here, okay? Whatever you're putting at the bottom here, okay? if you want to refer to that, okay, this is called, they refer to this as a mud plate, okay? Because it's basically usually sitting in the mud and it's a plate that helps to, so if ever you're referring to that bottom, it's called a mud plate. Okay, that's what they refer to in formwork. And that's it. So now you know that you're good to go. And as long as you can, and that's it. So does anybody have any questions? Can I stop? Everything's good? No questions? Everybody's clear?
So far, so good.
So far, so good. Like I said, guys, it's more of a review. You understand? It's more of a review because it's just to show you. Because some people have this fixation that, well, if it's floor joist, how do I apply it to formwork? Well, a load is a load. You understand? And you can change the factors. The fact that the load is short term. The fact that so like a bearing wall is a bearing wall, whether it supports concrete or supports a floor, it's a bearing wall. So as long as you know what loads that the wall has to carry, you can actually calculate the spacing. The only nice thing about formwork is that since it's a very temporary structure, well, you don't have to get hung up on that standard spacing of 300, 400, 600. You can go down to 100, you can go down to 150, you can go down to 200, whatever you want, because it's a very temporary structure. And therefore, as long as it has a resistance to do what it has to do while the concrete is being poured and it starts to set, because one of the most, like first of all, it can be dangerous. If the formwork ever collapses, people can actually get killed. Again, it has happened in the past. Okay, and of course that's your first concern. And the second thing is that like it's nice when like it all gets calculated properly, and they go ahead and they do the pour and everybody gets off the slab, and 7 days later they remove the thing. You know that total success, everything went perfect. You understand? So I'm going to stop sharing this and I'll put this on pause for now.
I just need to like put it in wording. Give me 1 second.
Okay, so what's your question?
Give me 1 second.
Go ahead.
So I was doing the calculations for the number of nails. I reached a certain number of nails for the
For the truss.
yeah, for the truss.
Okay.
So then I was wondering, like, because I'm not really sure, like, on how to like picture it in my head, like when, like, because of the end distance. So like actually I don't know how to put it in words.
Take your
Like,
time.
where does it
Take your
start?
time. Take your time. So in other words, okay, so
Can you put like a whiteboard so just so I can draw something and maybe it would
yeah,
be
there you go. How's that?
okay? Thank you. Okay, so like for example, this that's here, right? This is the side of the trust. It's very crooked, but like, and then there is the bottom chord and the top chord here. Oof, it's really bad.
I follow you totally, so don't worry about it. I've drawn worse than that, and I've been drunker than you. So
Okay, so that means like my end distance here, like where do I start? Like, I know you said that it doesn't matter where, like the carpenter is the one that's gonna have to figure out where to place the nails.
yeah,
But like for the gusset place, like, is this my end distance, or do I start here and then my nails will start be
it,
here? How do I draw it in
it,
AutoCAD?
well, you don't draw it, but see, because like you're not gonna
Yeah,
like.
not the nails, but I mean like because it would depend like where does my end
Well,
distance start?
if you're gonna do it with AutoCAD, if you're gonna do it with I think I showed you this last week if I'm not mistaken,
Yeah, yeah.
but if you're gonna do it with AutoCAD, for example, I think last week what I did, I actually very quickly drew the truss if I'm not mistaken, and then I came up and I was able to determine this, right? And what I said was, okay, you know that, for example, with AutoCAD, the nice thing about AutoCAD, it does all the calculations for you. You just have to give it the command. So with, like, for example, if I take this member here, I'm going to put it up here, okay, so we can all see it. Well, let me clear this. So with AutoCAD, what you can do, okay? Okay, you know that with AutoCAD, for example, I'm going to change color so you can see this. Okay, so with AutoCAD, what I would do is I would draw a line here. Okay, Ryan?
Okay.
Yeah, and then just to make it easy, like I'd make sure the line touches here. Okay, I know that it has to have a perpendicular distance of 40 millimeters. It's 39 minimum, but 40. You understand?
Mhm.
Okay. So what I would do with AutoCAD is I would draw a line here and I'd say offset. I would take the offset command. Okay, offset. And then I would say 40 millimeters. Okay. And then I would pick this and I would point here and AutoCAD would put it there. Okay.
Yeah.
Okay. Then with AutoCAD, what I would do is I would say offset. Okay. And now I wouldn't give it a distance. I would say through. Okay. With AutoCAD, you can actually pick a point and it will go through that point. So you would pick this line here, and then you go pick this endpoint, and AutoCAD will put it right there for you.
Oh, okay.
Do you understand? Because if you say 40 millimeters, it's going to offset 40 millimeters perpendicular like this instead of 40 millimeters perpendicular like that. You understand?
Okay.
You follow what I'm saying?
Yeah.
So by saying through, AutoCAD will go through that point. Okay? Now, what you can do is then after that, you take this and you offset. I think we said we should leave what? I think we said we're going to leave 60 after that, right?
Yeah.
So then you can put, offset this to 60 here, okay? So you're always going to make, and then after that, you can do another through, you understand? And then like if you saw what I did last week, I just, so once I got this point here, okay, and then I said copy, okay, and I said copy this, start with this point here and go to that point there, go to that point there, and I was able to just keep copying those all the way across until I ended up with the number of spaces I needed. You understand?
Did you record that last week?
I think so. I think so. But if you want, we can do it again.
No, it's okay. You can just look at the video.
No, but you understand. So like the thing is, Rena, for me, for me, AutoCAD is a great tool. You understand? And I like to use that tool and try to maximize how I can get the most out of it. So if you didn't realize that you could use this through command with AutoCAD, you would never have thought of that. You understand? You know what I mean? And it's just that's all it basically is. So, and then the same thing here, for example, like, well, here we don't have to do it, but for example, this one. Okay, so that's and then once you determine, like, for example, like how many times you have to repeat this pattern in order to get the number of nails you want, well, that's, and then with AutoCAD I would have just, like, ask it for that distance there, and of course after that bring it up to a multiple of 10. You understand? And that would be the size of my gusset plate. But I think I did it last week, and I think it's on the recording. Okay.
Okay, I'll go look at it.
Okay. And of course, if you can do this complicated one, the other ones are going to be much easier. You know what I mean? Sounds good?
Yeah, thank you.
You're welcome. So, well, if you're there, that means you're pretty well finished your project, which is great. So, I mean, first of all, there's only 2 weeks left. Anyways, I don't know if you guys noticed this, but I did put the project on the assignment sheet. Did anybody notice that?
Yeah.
Okay,
Yeah.
so keep in mind that if it doesn't come in by the time I have on that assignment sheet, you will lose 50%. Okay, and that means that as far as you fail the project, because if you lose 50%, you're at 50%. You don't even have 60, so you failed the project. Okay.
So we also send our AutoCAD file in the same.
But through Mayo, you understand?
Oh, okay.
Because I want to keep the PDF in one folder. I want to keep all your drawing. First of all, you're only going to have hopefully you're only going to have one AutoCAD file. Understand? Because you're just going to copy and you're going to put everything on one sheet, right? Like I showed you. So I'm going to basically be getting one AutoCAD drawing from you guys. You understand? So Anton, you raise your hand. Go ahead.
Yes, sir. I have a question. Since the last exam we did built-up columns, bearing wall, and lintels. So for this exam we only have nails and formworks.
Yeah, isn't that
Okay.
nice?
Okay, perfect. I just wanted to clarify that.
And hold on. So what I'm going to do is, hold on. Let me just see if I have. Yeah. As a matter of fact, yeah. And if you want, I can send you the exam the day before. How's that? Does that sound good?
Are you joking?
Of course I'm
Yeah,
joking,
be
because
perfect.
the day before is a
too good to be
strike. I'm
true.
not allowed to do it. So now you know why I'm saying that, because it's a strike, right? So that's why I'm saying that. I'm just kidding.
Okay, good. And for the steel, it's from a 7765, if I'm not mistaken.
Well, the steel is going to be Monday morning. Like, guys, for the steel, like I said, 8 o'clock, the exam's going to go out through the assignment at 8 o'clock, and I'm going to expect you to hand it in through, also again, through Leah by 9:30. Okay? Because I find that the Leah, the assignment is great because it has your name, your family name first. It just organizes everything for me very nicely. You understand? So
Yeah, because I remember on the second exam we did the base plates. So
well, the second exam is going to be a connection,
the third.
a connection, and you're going to
Okay.
have a double angle connection. In other words, you have one bolted connection, and you can then redesign as a welded connection, and then
Okay.
after that, you're going to have a bolted connection. Like, in other words, I believe it's the last 3 assignments.
Okay, perfect. All right, perfect. Thanks,
Okay,
sir.
so just so we're all on the same page. Is that okay?
Yes, sir. Thank you.
So how are you guys doing in terms of, are you keeping up with the workload, or are you now starting to feel the big crunch?
I have a couple questions about this still.
Go ahead. Let me, do you want me to leave the whiteboard? Do you want me to stop sharing the whiteboard?
Well, my first question is, I don't need the whiteboard. I just need to know, because I noticed you have the table 3.4, but you only have it in your PowerPoints. You didn't send it individually. Am I right?
Table what?
3.4 for the factor, shear, and tensile resistance.
Factor, shear, and tensile resistance for what? For welds, for bolts, for
Oh my God.
you know,
Bolts.
you're giving me too much credit. You know, if I were you, I would go and check the lectures where you're referring to, and I would open up the folder. It's probably in that folder.
Yeah, like I open all the folders, but I usually you send us like PDF of every table, and then it's in your PowerPoint. But this one I can't find there, or the 3.6 for bearing type connections. I can't find these two tables. So
Okay,
I was wondering if maybe you put
okay,
it
hold on
somewhere
a
else
second.
because you didn't notice.
Hold on a second. Tell me. Okay, so hold on a second. We'll just double check just to make sure we're all on the same page. Okay. Okay, so let me just. Okay. Hold on. I just want to go see. Now, so Rena, what are you referring to exactly? Like, tell me, are you referring to bolts? Are you referring to, because when you say table 3.4, I have an idea what it is, but I don't know, because I don't memorize the table. Do you understand?
Yeah, it's from the bolted connections.
Bolted connections. Okay, so I'm gonna go. I'm looking in my file folder right now. Okay, I'm going to my file folder. Hold on a second. Steel structures, lectures, bolted connections. Okay, so yeah, you're right. I didn't add the table here, right? That's what you're saying, right?
Yeah, like I watched the video and then I could.
No,
take
you're
it
right.
out.
I didn't. For some reason, I didn't put the table. I didn't put the table in the. You're right, because I just added it as an extra slide in the PowerPoint.
Yeah, I
right?
didn't find it too. I was looking for it, sir.
Yeah, so you guys are gonna have to open up the PowerPoint and make a copy of that table from the PowerPoint.
Okay, yeah, I already did that. I just wanted to
Okay,
know.
that's the best way
that
for me. You know, like
homework.
I'm sorry, I didn't realize. Yeah, I'm glad you brought that up. I thought like I usually add all the tables, and that in this one here I didn't do it. So you're just gonna have to like And don't forget, just print that one slide and make yourself a PDF out of it. Understand? But hold on a second. I want to see if I have, because wait a second. I want to see where. I wonder why. No, yeah, it's funny because I can't find the table myself in my own. I have table 325. This is what table 323 you said?
It's labeled 3-4 factor shear and tensile resistance.
Yeah, I know. And unfortunately, for some reason, I don't even have a copy of it myself. I just have that PowerPoint slide. Understand? So I want to see if I can.
There's also the table 3-6 varying type connection.
Yeah, I just want to see something. Yeah, no, I don't have a copy of it myself. Understand? I must have just added it into my PowerPoint. So just like I said, make yourself a copy from your PowerPoint. Yeah, it's table 3.4. I know which one you're talking about, where you get the shear resistance of the bolts, right?
Yes.
That's the one. Yeah. Yeah, just make a copy from the PowerPoint.
Okay, yeah, I already did that.
Okay, sorry about that. Yeah, you're right. I usually always give you the table on top of that, but for some reason this time it just didn't happen. And
Sir, I just have
yeah.
about the AutoCAD file. Do you want us to send it like printed on one page, like the ANSI expanded B, like you wanted, or just the file itself, so you can look at what we actually did?
Well, okay, let's make sure we're all on the same page here, okay? And I'm going to go back to the whiteboard so we're all on the same page, okay?
Yeah.
Okay. You're going to have your design brief where you have all your calculations, like I said, right? Fair enough.
Yeah.
And then in addition to that, in that design brief, you're going to have drawing number 1,
Oh, okay.
drawing number 2, drawing
get it.
number 3,
That's
drawing
yeah.
number 4. Okay, that's all going to be in there. Because if we were in school, okay, if we were in school, I would even show you how, like, this would have been printed on an 11 by 17. You understand?
Right.
You would have
That was
printed
my question. I was like, did you want it all on one
all
template?
in one file, yes. And then this is what I mean by all your PDF here. This is, like I said, this is all
Right.
going to be in one file. And then after that, separately, you're going to give me your either your AutoCAD. I'm saying AutoCAD or Rivet because some people are using Rivet file. And I know that if you're sending me the Rivet file, it's going to be one file. If you're sending AutoCAD, it's going to be one file. You understand?
Yeah.
So,
Okay. Now it's clear.
Now it's clear. But see, like, because if we were in school, I was going to show you how to fold this properly so that how you insert these in your reports. You understand? Like, basically what you do when you have an 11 by 17 like this, right? Okay. What you actually do is you take this and you fold it over and okay. You understand? So you end up with something like this is totally covered now. Then you take half again and you fold it over. And therefore, what you actually see in your report is something like this, okay? And it's folded like this, and therefore I can just open it up and see the whole drawing, you see? So I would even show you how to fold properly 11 by 17 when you put in your reports. But,
Great.
But we're not handing in a hard copy, understand?
Yeah, okay.
Because if we were at school, I would ask you this whole thing to be bound, you understand? Just
right,
like you
like the real report.
Yeah, exactly. This will be bound with, a nice little cover sheet. And then at the very end, I would have drawing number 1, number 2, number 3, number 4. Understand?
Yeah, okay.
But
Thank
now,
you.
like, you're just going to have to include it as part of your PDF, right?
Yeah.
Sounds good?
Yes, sir.
So I know, I mean, the advantage of, the PDF is that we're saving a lot of paper, a lot of printing, but at the same time, I still like to work with a hard copy, you understand? I mean, correcting your exams on the PDF is not as it's a little harder than if I would have a hard copy. You understand? I mean, it's still doable because what I do is I use Microsoft Edge to correct your PDFs. You understand? Because I with the Edge I have all kinds of markers and stuff that I can mark and stuff. But anyways, okay, so that's clear for everybody. So this way we don't have any and guys, like I said, make sure that it's in the order that I specify on that sheet, okay? And then, because I don't want to have to go look. If I have to go look for information, I will assume that it's if I expect the information to be here and it's not there, I will start deducting marks. If I go on and I see it there, I will disregard it and I will just deduct that mark from your project. Okay, keep that in mind because I don't have to go. I shouldn't need a roadmap to discover where I need to look for the information. As a matter of fact, the design brief follows the chronological order as if you actually be designing the project, and I expect the calculations to be in the same order. And then at the very end, of course, once all your calculations done, I should be able to find all your drawings here. And of course, those should also be in sequential order. So, all right, so. And those of you that have been keeping up to on a week-to-week basis, well, this is when you're going to be appreciating the fact that you put in the time way back when, because this is where it pays off, because the last 2 weeks are horrendous. You understand? I don't know if you guys are feeling the crunch right now, because that's the biggest complaint I hear every winter. So
I've been keeping up and I'm still stressed.
oh, I know, but at least you're a little less stressed than if you wouldn't have been keeping up. Trust me. You understand?
Yeah.
And I believe it or not, I think I've had people drop the course because they couldn't finish the project.
That's unfortunate coming so far, yet so far again.
Well, exactly. So like, and that's why,
Almost thought about it.
if you remember at the very beginning of the semester, what I was telling you guys, remember? I said, just keep up on a week-to-week basis. It's going to pay off, and even when it was your spring break, I said, if you guys have a chance to work on your drawings a little bit, you're just, banking a lot of time that you won't have when you get to the end of the semester. And that's exactly what happened.
Oh.
So,
Sure.
yeah, yes.
Do you mind if I will share my design for the gusset plate and the number of nails, and you would tell me if I'm doing it right or not?
Sure. Let me just stop sharing this. Share me your thing. Did you do it on AutoCAD?
Not really. I haven't got this far with the AutoCAD. I just
Wow.
made the design here.
You're going through all that trouble?
Yeah.
Why?
No, just for me, the thing is, okay, the gusset plate, it's like showing here, it's fine, but when I try to picture it on the truss itself, I'm not sure how it's done. Like, I will give you an
I have the
example.
same
This,
problem.
huh?
I have the same problem. That's why, like, I did almost the same thing as you did, and I had the same problem.
Yeah, but you see,
Like,
all I want to see on your drawings, for
that-
example, you've determined that here you need, this is 500 millimeters. Is that it?
yeah,
1 foot.
yeah, for
Okay,
36 nails.
so if you're doing your drawings in imperial, all I want you to do is I want you to show me that the length of that gusset plate is 3 feet. What is it? 8 and 8 is 16. 3 feet 4 inches. That's it. You understand? If we look, if you go now, let me. I haven't opened up a drawing, but if you
Why it's gonna be three? Why it's gonna be 3 feet?
well, because you're saying that half the gusset plate is 1 foot 8 inches. If you take the full length of the gusset plate, it would be twice that.
Okay,
Yeah,
but that's for
this is
joint
the
2.
part that I'm not getting actually.
Pardon?
Uh, okay, this is for joint 2. I wish if I had the
I-
trust.
w- w- This is joint number 3 that you worked this out.
Which one?
Like here,
Which sheet?
like in other words, this was for joint number 3, right? That you worked this out, the spacing here. Is that it?
Uh, joint number 3. Yeah, 12 nails.
12
This is what
nails,
I
and
got.
you and for you to be able to put 12 nails, you need 8 inches. Is that what you're saying?
Yeah.
Okay, great. And then here you have 24 nails, and you need 1 foot 2 inches. Is that what you're saying?
Yes.
And then, okay, so I just want you to appreciate this, okay? Like, look, so for joint number 6, you said you need a distance of 320 millimeters, right?
Yeah. This is the one that we did it in the class.
Okay, hold on. We did that one in class?
Yeah. For joint
Okay,
6.
okay, so this is the one for the bottom truss, this one you're talking about, 1 foot 8 inches. Is that it?
Yeah.
Huh?
Yeah.
Okay, so
That's it.
so the reason why I said 3 feet 6 is I saw this as being a butt joint. You understand? Okay, so
Okay.
can like can you split your screen and open up the drawing where the truss is? Can you split, like put this on one side and put the truss drawing on the other side of your screen?
I don't have the trust drawing.
You don't have, like I sent you like the 4 of them.
I open mine. Then you
Well,
can
it
share
depends,
yours.
because can we split your screen and her screen at the same time? I don't know if we can do that.
I have no idea if it can be done, but I can just like stop sharing so Reina can.
Well, okay,
share
look,
it.
what I'm asking you, okay, open up your truss drawing, and I want you to remember these dimensions, okay? So like, okay. So I'm going to ask you these dimensions. I'm going to show you how you relate it to the drawing. Okay, Norman? So can somebody open,
Okay.
so stop sharing yours and somebody open up the,
If you I just need to get the trust drawings on this computer because I have it on a different computer. If somebody has a question, can go ahead and ask it till I can just make the.
no, all I'm saying is that
open.
I understand what you did here. You basically worked out all the spacing based on the number of nails you calculated for each joint. You understand? Okay.
Yeah.
So that's great. Now I'm going to show you how easy it is to take this information and put it on your drawing.
Okay, so what do you want me to do now?
Open up a truss drawing. But just, I want you to,
I don't. I need you to give me time to move it from one computer to the other.
if you can open up the truss drawing, in other words, drawing number 4, right, that I sent you, and put on one side and then put this on the other side, so I can, show you, point that, and show you how easy it is to take this information and then put it on your drawing. You understand?
Okay,
Because now
actually,
you've worked out all the dimensions. You understand?
Yeah.
So it's very easy now. Now that you worked out all the dimensions, I'll show you how easy it is for you to come up with your gusset plates.
Okay, one moment. I'm just gonna open the.
I can open mine if you want.
Go ahead. Do the
Oh,
please.
Norman, just to let you
Yeah.
know, can I, I'm gonna annotate something here, okay, Norman? I just noticed
Okay.
something, okay? This is a no-no. This is a no-no. Do you understand?
Okay.
Like
I cannot
the only time that you're allowed putting a nail in between, if you respect that minimum distance of, you
60.
understand? Yeah, so here you don't have 60. These nails are one beside the other, so this is a no-no, okay?
Okay.
See, if you maintain that that A distance, they're saying that if you maintain that minimum A distance, the distance parallel to the grain, right? And everything else, then you're allowed you're allowed to stagger. Stagger means that they're not in line, okay? Additional nails in between. You haven't done that here.
Oh, okay. So the no thing is because we should not be online.
No, what I'm saying, the no thing is you're not allowed doing this. You can't, sorry, I'm trying to erase and I can't seem to erase. How come I can't erase? I have to ask for permission, right? Yeah, okay, so thank you for, the no thing is this, Norman. This is like, this nail is in line with this one. You understand?
I cannot see your
Right
even,
here.
like,
Can you see
your,
me here? Can you clear all the
yes.
drawing?
Yes.
Okay, this
Okay, now
is
it's
in
clear.
line, and see the way you're drawing it here. This line and this one are in line. This one
Yeah.
and this one. So if they're in line, you have to maintain that minimum distance of 60.
Okay. So I can put them in between the other two.
Come
Where-
on.
Sorry. So do you understand, Norman? What this is no good here? You're allowed
Okay.
doing this here because you're maintaining the 60 between these two, and these two. So you're allowed staggering in between. You haven't staggered here. You kept them in line. So this is a no-no. You understand? Like this is a no-no.
So where would we put that nail then? Or like
Just move it over by another 30.
Okay.
You know?
All right.
I mean,
Yeah,
why are you so hung up
Okay.
about giving another 30, another inch? Do you follow what I'm saying?
Okay. Yeah, I got you. Okay.
What's there to stop you from putting another row here? Like, what are you worried about adding another inch to your gusset plate? And therefore, you could even increase the number of nails if you want, because you have the room. Understand?
Okay. So this one.
All I'm saying is that right now you got 9 inches here, right? I would say that becomes 10 inches. You understand? That's all I'm saying, because you cannot do this. You're not allowed putting 2 nails in line. Like, do you understand? The C distance is this, Nermin. Do you understand that? This
Yeah,
is
yeah, yeah. Yeah, I
I'm
do
sorry, this
understand
is that A distance that we were talking about. Now, if you maintain that distance, you're allowed to stagger in between, but they're not in line. That's what they mean by staggering. Okay. See, now the distance between this one and this one is more than 52. The distance between this one, like the distance between the staggered nails, you're still maintaining that minimum A distance. I don't know if you understand what I'm saying.
No, I do understand, but I thought as long as like the problem that because it's
No, like,
online.
and I thought I was very
Yeah.
clear on that. Like, you have to understand the whole concept of those. What the
I
A,
do
B,
understand.
C, D stands for is the direction of the grain and where the nails are with respect to that grain. Okay, so in other words, this nail here, and so this nail here, if my, did somebody erase my thing? Can you see me draw 2 circles here? How come they keep?
I'm trying to.
No, we
It's
can't
full.
see it.
Okay. So, anyways,
I can reopen it if you want.
so you're gonna share like well, I can go get the I can go get the draw. It's gonna take a while, but I can go find the drawing.
Just I'm there already. So just
Okay,
give me-
so good. So share the drawing.
Okay.
So you worked out all the distances, right? Like I said, you made there's a little glitch, but don't worry about that, Norman. You understand? Are you sharing your drawing?
There right now.
Okay.
Here it is.
Okay. So what you're saying, can I annotate? Okay. Let me annotate, okay? I'm annotating now. So on what you showed me before, what was the distance you had here?
It was 500 milli, so it's
Well, give it to me.
it's 1 foot 8 inches.
1 foot 8 inches. And how many nails
Yeah.
did you put in there?
36.
Sorry, 36. Okay. So basically, and you calculated 1 foot 8 inches from there to there. You understand?
Yeah.
Okay. So what you're going to do is you're going to do this. you're gonna, on your drawing, you're gonna offset 1 foot 8 inches, okay? And then you're gonna measure from there to there and round it off to the closest inch.
Yeah, okay. For this joint, I get it, and for
Okay,
the joint,
now
as you call it, the bottom.
let's look at let's look at joint number 3. This is joint number 3 here. Okay, Nermin,
Okay.
that's joint number
Yeah.
3. According to your calculation, what was the distance that you needed to put the number of nails?
12. Yeah. It was 12 nails,
Okay,
and
but
it's coming to 8 inches. 8 inches.
8 inches. So for what you're saying is that from this point here to that, you draw a line here and you offset it 8 inches, and that it would give you that line there. You understand? And then you can determine the size of your gusset plate. So you've already worked out your dimensions, Nermin. You understand?
Okay. My problem
let me blow this up for you. See, you drew it straight like this, and you worked out your nails. You understand? Now, I'm going to take this member here, and I'm going to draw it with the same angle that it's supposed to be in the truss. You understand? Okay, so what you did, you calculated if it was straight from here, and you said that you needed 8 inches to put all those nails. So you're saying that from that point there to that point there, you need 8 inches.
Okay.
You understand? And then you draw a line perpendicular to that, and then you'll be able to dimension what that is.
Okay.
Now,
and
now
my problem
let's go. Like I'm just showing you how easy. Now you've worked out the hardest part. You understand? Now you're just going to take AutoCAD and you're going to simplify your life. Now up here, what joint was this?
It was these are four joint 4.
And okay, so on your joint 4, what distance did you calculate to put all the nails that you needed?
I have 9 inches.
Okay, so if let me blow this up here. Okay, so this is what
We
you
need
have
to
here.
do a bit
Okay,
of adjustment.
you have this like this. You understand?
Mm.
And what you calculated, you said from here to here, I need 9 inches. That's what you said.
Yeah.
Okay, so on your AutoCAD drawing, you take a line here, you're going to offset it 9 inches, and then you just draw a nice straight line, and you go up, and you got your gusset plate. My God, you got all the information right there.
So I'm gonna.
You understand?
Like,
like you're drawing everything straight like this, and you're calculating what the space you need, right? Well, then when you get to your drawing, this is the straight part. You understand? That you have on the other drawing. That's why I wanted to show you. If you could have left both drawings, I could show you how you relate that to that.
I don't know how to put like both of them next to each other.
Well, you press the. Do you have a Microsoft key on your keyboard?
What?
Do you have a Microsoft a Microsoft key on your keyboard? Are you using Windows 10?
Yeah.
Do you have a Microsoft key on your
No,
keyboard?
this one. This is an ancient laptop that I have.
Oh, it's a laptop. Okay.
So I can, yeah.
Okay, no, okay, so okay, you're using a laptop. Okay, but you understand, Norman, what you've done is that you've worked out, for example, even this looks like this one here. This looks like it's like this. You understand? It's like it goes like this. It goes like that. What you did is that you put everything straight like this, and you worked out what the spacing was, right? So when you come to this joint here, you would be starting from here, and then you would go and offset that way, and that would be that straight distance that you worked out, and then you just let AutoCAD do the rest of the calculations for you.
Yeah. No. Okay. Now I got it.
Now you get it.
Okay. For the where it says G4 on the drawing.
G4.
Which is
no G4 is just
on the drawing.
Yeah, the G4 is just to refer that you come down here to get the size of the plate.
Yeah, I know this gusset plate. It has like 4 different of loads there, or of joints. So we're the way we're gonna design the gusset plate is just gonna put like nails according to each joint, right?
Yeah, I'm not too crazy about this gusset plate. These aren't necessarily, you understand? Like, if like, let me just show you. Okay, I should open up the AutoCAD drawing because this way you would see how nice how I would take your information and do the gusset with the information that you use there. You know, like those little sketches you made.
Yeah,
Pardon?
I I saw the lot, like I was there for last lab when you did the first drawing and how you
Yeah. So
designed it.
what I'm saying is that for this joint here, right? Can I clear the drawing? Okay. So let me show you. Let me show you on my whiteboard how I would, based on the information that you have,
You want me to
how
stop there?
pardon?
You want me to stop there?
Like, I'm going to show you on the whiteboard how I would do it once you have that
Okay.
information. Okay. So let me show you. Okay. So so if I was in AutoCAD right now, okay, this is the bottom chord here, right? And I don't remember exactly if the members, did you put like did, did you put the members this way for the bottom chord? Is that how you did
Yeah,
it? Right?
yeah, yeah.
Okay. So look, I'm going to change color so you can see what you're doing. Okay. I just change color. I'll do it in blue. Okay. So right now, what you did is that you took a straight piece of wood like this, right? And you calculated, for example, my edge distance here, and you calculate how far I would need for to have all those nails in that space. You understand what you did?
Yeah, yeah, of
Okay,
course.
that's what
Yeah.
you did. And then you said that for this joint here, you had 9 inches. Is that what you had?
Yeah,
Okay, so what you're saying is that from here, okay, if I take the same straight piece of wood, just in your mind, superimpose it like this. Isn't that what you're doing?
yeah, yeah. Now I get, no, I got it now.
Now you see
How
it, you
it's
see?
done.
So what you want to make
Yeah,
sure of
yeah,
is
yeah,
that from here to here, you have 9 inches.
yeah. Okay.
Do you understand?
Yes.
So now, if this is
And
the case,
for
like
the
what I would do is that my gusset plate, right? I would go, so here I would go down straight. I would make that at an angle there. I would go straight, make that at an angle there, and make it go straight. Isn't that a nicer gusset plate?
yeah, absolutely.
You
But of
see?
course, it's gonna be like because the next
But you
there's
understand what I
a
mean? Like
different drawing.
you've worked out the worst part. You know?
Yeah,
with,
yeah,
with that information that you had, like if you were in your AutoCAD drawing, it would take you about 2 minutes and you'd have all the size of your gusset plates.
yeah.
Okay.
Yeah, okay.
So, but you
Yeah, I
understand
got
what I'm saying? Like how what you did here, just in your mind, superimpose it on the member as if it's, and then from there work out how you're gonna make sure that you maintain whatever you worked out there inside there. You
Do
don't care
our
about
gusset
this. You don't.
plates
You understand what I'm
have to
saying?
be like this?
Pardon?
Do our gusset plates have to have this shape?
I'm sorry. You have to. What's your question?
If the gusset plates have to have this shape in particular, because I was looking in the internet and there was like different shapes of for gusset plates.
Rena, there's not one right answer. What's wrong is if there's not enough space in here to put the nails. You
Okay.
understand? So if you want to make this pointy, if you want to cut this at an angle, it's up to you. You understand? But what's wrong is if there's not enough space here to put the nails. That's wrong. If there's not enough space here to put the nails, that would be wrong. Here there would be ample space, trust me. But by the time you do this, there would be ample nails to put the, you understand? From here to here. I'm pretty sure that this will be ample space to put the nails that you need from that one and that one. But this, to me, is a very nice, clean gusset plate. If you go, like I'm saying, see what she did is she worked all her spacing based on the members being straight. And I'm just trying to show her how you take that straight member and you superimpose it here. And then all of a sudden you take that, whatever you worked out there, and you do the rest on the AutoCAD, and you let AutoCAD give you the dimensions here. You understand? So that's what I'm saying. If you don't do it on paper, then you start, like, for example, you put your nails, you do the offset, and then you find out where it goes, and you can actually draw it on AutoCAD. But she's already done this manually, so therefore she already knows what these dimensions have to be. See? So that's, it's, so I'm glad it's clearer now, Nermin, you understand?
Yeah, thank you so
Okay,
much.
so like you were just having trouble relating how I'm doing everything straight, and how do I relate it to something that's at an angle, right?
Yeah, and especially when you have like for the bottom one, you have like a three different joint at the same point. So I was not sure how we can
Well,
put
like
the
I
whole
said,
thing in
I
one.
superimpose a straight. I superimpose a straight one right on my truss drawing, and then from there I simply draw out my gusset plate. You understand?
Yeah, yeah,
And you worked out the worst part. You
yeah.
know, that's it. So
uh,
okay,
But it's fun. It's
it's
nice.
fun, right? It's fun when you
Yeah,
okay. So that's it. So there you go.
I'm not complaining.
So guys, look, I'm glad you guys are having fun with this, because it's supposed to be something, well, of course, I want you to learn at the same time. I don't want you guys to get overstressed. And if you have problems, I mean, I'm here to offer you all my expertise in both with AutoCAD or with whatever it is that you guys need to be able to simplify your life, So don't get stressed out.
Thank you.
And that's why I want to take this lab time and, throw everything. And guys, whatever problems you're having, probably 80% of your classmates are having the same problem, or they're not there yet, and they will eventually, when they get there, at least they'll have a better idea of how to handle it. So don't be afraid. Just,
Sir,
yes,
I
Omar,
have a question.
go ahead.
I'm gonna share my screen real
Yeah,
quick.
by all means, that's what we're here. The whole afternoon
Um,
is just to talk about oh,
this is
nice.
this is a photo. Okay.
It's a photo.
Yeah.
Okay.
For now. Um. So a quick question about this, the bottom one here. First of all, do the nails have to be? I mean, do the lines? You see that?
Never.
You know.
You don't show any lines. Okay.
No,
You don't.
no.
No.
I'm just doing when I do the calculations. Do they have to be perpendicular? Like when I do offset, 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 offset until I get the gusset plate. You
Okay.
know?
So let me show that. Well, look, Omar. Okay.
Yeah.
Okay. What I want you to do is I want you to do things that are correct. That's what I want you to worry about. Okay. Number one. Okay. So let me annotate. Okay. Now, Omar, if you understand what that diagram is saying, you'll understand how to relate it to your AutoCAD drawing.
Okay.
Okay. So for example, now I'm going to go back to the table. On that table, you had dimension A, you had dimension B, you had dimension C, you had dimension D. Okay,
Okay.
right? Now, in that table, the A dimension referred to the spacing of your nails parallel to the grain.
Okay.
You understand? So if
Got it.
this is my 2x4 here, and my grain is definitely going like this, okay? If I put a nail there, right? And I put another one parallel to it, okay? I have to maintain that distance of, well, 52, but we're using 60,
6. Yeah.
okay? Do you understand?
Yeah.
So what I'm saying is that now with AutoCAD, what you do is if I determine that line here and I offset it, it's going to be exactly 60. So I'm
Exactly.
respecting the A. You understand?
Oh, okay, okay, I see.
You see,
But
that's what I want you to understand is like AutoCAD, like when I say like you draw offset, 60 millimeters, what you're doing, you're respecting that 52 millimeters when the two nails are in the same row.
I understand. Oh, okay, I see that. Okay, but my problem is I cannot. I'm right at the bottom here. I can't get perpendicular line like to start with to offset it. Like
You can, you
okay,
can, and I'll
okay,
show you like what you're like for
okay. One
example here.
second. Let me share.
Share me your AutoCAD drawing.
Okay,
You understand?
let me open it. Let me open it. 1 second.
Can I share mine?
Well, share. I don't care as long as I have an auto. Because if I open up my AutoCAD drawing, we'll probably take
Can
about
you
50.
see it?
Okay, so now I'm gonna have to ask for a remote request. Okay.
Okay, there.
Okay. So do you see my
Yeah, I see your cursor
Is that
moving.
me doing that?
Yeah.
Okay, so Omar, first of all, let me zoom in and let me pan over. Okay, now I don't know why your lines aren't touching here, but so Rena, I don't know why your lines aren't touching here. Is there a reason?
This is my draft, so I
Oh
haven't.
no, okay. Because what I wanted to do is I want to show. Okay, so we're, for example, okay, extend. Okay, so Omar, you want to see how you draw a line perpendicular? You say line. You start from that point there, and then you go. You make sure the O snaps are on. Make sure the perpendicular is on. Select all. This is the first thing you guys do. Make sure all your O snaps are on. I don't see how you guys work without this. I don't know. And then there,
I didn't even know that existed.
there's perpendicular, Omar. You see? And now I say offset 40 for my edge distance, right?
Sir, it's not for, it's for, this is inches. Anyways.
Oh yeah, it's true. Okay, so in other words, it's oh yeah, it's 40. Well, 40 divided by, okay, so this is inches. You're right.
You
So
can
in other
just
words,
write 40 inches and then it will do it.
pardon?
You can just write down in the AutoCAD 40 inches, like with the sign of the inches, and then it will do it.
No, because this is in inches. I'm doing millimeters. 40 divided by 25.4 equals, so it's 1.57. Okay, so offset 1.57. Okay, so yeah, thank you for reminding me about that, Omar. So there's your edge distance, and then the other one we said was 60, right? 60 divided by 25.4 equals 2.36. So offset 2.36, and then, okay. So Omar, you see how you get your perpendicular distances? And then you keep going, and
Okay,
that means
I
that
see.
you know, like I have 3 nails, and then here I have 5 nails, so I'm 8, 13, and you keep going until you reach the number of nails you need, and then you offset another 40 millimeters, 1 point whatever it was. You understand? And that's going to be the size of your gusset plate.
Wait, sir, can you just redo that step? Where did you connect? Where did you start off from? The corner?
I started right here, where I need a minimum end distance of 40 millimeters, right here.
Yeah, exactly.
And then what I did, I took 40 millimeters divided by 25.4. 40 divided by 25.4, because this is in inches, it's 1.57. So then I did offset 1.57, that's 40 millimeters. Then it's supposed to be 60 millimeters. So then I understand. And then, so
Because the problem is my truss
yeah,
doesn't come down all the way to the member like that. Like,
why not?
if I can annotate here, these two don't touch the bottom over here.
Why not?
Because I followed the video and they come down like this, and there's a space between here.
There's a
But
space.
these come down like this though for sure.
So so in other words, what you're saying is that I have, it makes no difference, Adriano, whether you want to draw them like this, okay, or you want to draw them mitered. It's the same thing. So for example, I take them both to be correct. Don't get me wrong, okay? So now, if like, let me annotate here, okay? So like in your case, okay, what you're saying is that in your case, you have one member coming like this, it's mitered, and it goes like this, and then the other one goes like that, right? Do you agree? That's what you're saying.
Okay, sir.
Is that what you're saying? Or I'm sorry, no, I drew the mirror. Sorry, let
No,
me.
I was getting confused because I think I made a mistake on the one of the truss. That's why the perpendicular doesn't.
What you're saying is that, like, in your case, you have.
Sir, can I share my screen and show you what he means?
Yeah, go
Exactly.
ahead. Yeah, go
Please,
ahead.
Rena.
Let me. Well, let's clear this. Let's clear this drawing here. Okay, show me.
Here we go. So, what we
Yeah, perfect. Okay. So what you have to worry about, is where is the closest end distance?
Yeah,
Okay.
exactly, sir. So like, let me just annotate 2 seconds. I just want to tell you what I'm like. I don't have these two members here coming down all the way here.
Okay,
I
how do you
think
have them? Like
Like exactly like this. I did them like this.
it doesn't matter. He said doesn't matter. Like he doesn't have them.
oh, you mean
Like
like you didn't miter them. You left them
yeah,
like straight, right?
exactly.
Exactly. You're allowed to do both. You don't
Oh,
have to
okay,
miter
okay.
them. You can do both. Like in other words, some people like to miter their joints, and some people just leave the wood straight. It doesn't matter. Adriano.
Okay, that's okay. I got it now.
They're
Okay.
both
Okay.
correct. You understand?
It's
They're
the
both
way.
correct. You
Okay, the
understand?
drawing's
So
different.
like some people will miter the joints and put them all together, and other people will just leave them at 90 degrees. Okay.
Quick.
Okay, so that's why we won't have a 90-degree angle because we.
Like in other words, what you're saying that you left yours like you left yours like straight like that, right?
No, it's exactly the same way like Omar has it right now. Exactly like this. I have
Okay.
it.
Okay. So
Okay, so I thought. Okay, no, I thought it was wrong or something. Okay,
no,
never mind then.
it's like I said. Oops, sorry.
45. I think this.
Like I said, like they're like some people miter the joints and the trusses, and some people leave they leave the lumber coming at 90 degrees. They're both correct. Understand?
But like in the future, does it matter? Like, is it which one's better to do?
Well, like mitering is a little bit better, but it takes more work. The
Oh
guy
yeah,
has
for
to
sure,
cut
for
the
sure.
right angles.
Yeah, for sure.
so, like the mitering is a little bit better. So this way you're not relying totally on the gusset plate. Sometimes when they butt together, they might help each other, transfer some of the stuff. But but the reason why they don't miter them is because sometimes the guy can't even calculate the angle. You understand? Because you have to
Yeah.
calculate the angle for you to be able to miter those things together. You understand? Mind you, with AutoCAD, you can have AutoCAD give you the angle. So Omar, do you
Yeah.
understand how you draw a line perpendicular to whatever it is? So you take
Yeah.
the closest edge distance, you draw a line perpendicular to the other side, and bang, off you go.
No, I have them. I just was making sure. Okay. And one other thing,
And,
when
and,
we start,
like here, perfect. You see here's one of your end distances. Like here, can you see my pointer here?
no,
See? Okay,
where
that's
is it?
because I have to share. You have to request remote control. Okay.
Approve. Yeah, go ahead.
Okay, you're gonna have to zoom in. See here? Oh, sorry. Let me go back. I want to pan down. See here, this is perfect. You started here, you drew a line perpendicular, and then you went and you got your end distance, then you got your distance in for your A value. Perfect. You understand?
Yeah.
Don't even worry what happens in here. Who cares? You understand?
Okay.
You follow
And
what I'm
this
saying?
gusset plate, this gusset plate would be the minimum. I can extend it a little bit just to make sure.
Well, I mean, like right now, like if I come to what you're doing now, right? Now, if you, I'm gonna draw over it, okay? So if you want to, if you want to get really nice, like Omar, like be creative. Hold on.
Yeah.
What I mean by creative, where's the annotate? Okay. I mean, so what you're saying is that this is the edge distance to keep that from there to there, right? You understand? You follow what I'm saying? From here to
Yeah.
here is your edge distance from there to there, from the last nail you're going to be putting here in your joint. Agreed?
Yeah. Yeah.
So here, once you make a gusset plate like this, go straight up, go like this, do the same thing on the other side, go straight across, and isn't that a nice gusset plate?
I mean, okay, it would be nice here, but when they go actually cut it, the guy when they cut it, it's gonna be harder for them.
Pardon?
Anyways, yeah, okay, okay, makes sense.
Okay, so what you're saying, it would be easier for the guy just to do this. That's what you're saying, right?
Exactly. That's
Okay, do it
exactly
like
what
that. Like Omar, they're both good, you understand? Like, as a
Okay.
matter of fact, you're right. This would be a little bit easier for the guy to do it. So do it this way. That's good. You understand? Now up here, don't forget you have 2x6s. So there's a lot of rows you can put in here to put the number of nails that you need. You understand?
So I don't have to do okay.
Do you understand? Because here you have a 2x6. You don't have a 2x4. So there's a lot of space up here.
So I can add like an extra row, so I don't have to go.
Exactly.
Okay.
You understand? Because look, we said we needed 13, this is always going to the minimum, right? 13, 13 for the edge distance, 26 in between, right? Remember, like perpendicular to the grain, we
Yeah.
need 26. We need 13 for the edge distance, right?
Yeah,
So for
exactly.
example, if I have 1, 2,
Sorry.
okay, don't
Here,
worry. Like,
here's
well, I'm gonna go to
this.
my whiteboard so you guys can understand what I'm saying. Cause so,
Okay, I'm gonna drop out.
yeah, okay, so that's it. So like for the top chord, you guys have all this liberty. You understand? Sorry, let me go to the whiteboard, and we'll do the math right now. And I'm sure you can put 4 rows. Okay, so here's my 2x6 like this, right? Well, that's 140 millimeters, right? If I have to leave 13 there and 13 there, right? So 140 minus 26, how much is that?
Actually, you
140
can put like 4
minus
rows, but the thing
26,
is,
I have 114, right? And if I divide that by 20, I divide that by 26, I think we need for the, yeah, I can put 4 rows if I want, Omar, easily.
Okay.
You understand? So that's why, when, like up there, like you know that the carpenter has the
Okay.
flexibility of putting 4 rows. You understand? So you don't have to worry about going all the way out there. There's enough space in there to put the number of nails that you need.
Okay, I get it. Thank you
You
very
get
much.
it. As long as you get it, that's what I care. The rest, you understand? And this way, if you get it and if somebody doesn't get it, they'll say, hey, Omar, what did you get? And you'll be able to explain it to them. How's that? And you'll save me the trouble of having to explain it again. Thank you, Omar. How's that?
Yeah, sure.
I'm telling you guys, and I'm happy that the gusset plate is the last thing we do in the project, because I find that becomes, in theory, one of the more tedious part of the whole project is the gusset plates. You understand the concept of spacing, having to do the drawing and all that. And I'm glad that's at the very end, because if and at the same time, I mean, we can resolve whatever issues you might have, but it's really not that complicated if you understand what those distances represent. And if you can maintain those distances on your AutoCAD drawing, it's very easy to establish the size of the gusset plates. So the thing is to be able to relate to what is required and how you're going to be able to transfer that requirement onto your AutoCAD drawing, so you can let AutoCAD do the calculation for you. Understand? Whereas Nermin, she did the whole thing manually, and she had all the good information to simply put that one dimension right away and then finish her gusset plate. And now she knows how to do it. You understand?
and I was aiming for extra points or marks.
No, but Nermin, listen, Nermin, it's easy for me, right? You know, it's easy for me. I got gray hairs. You understand? When you get old and gray, it's going to be easy for you too. You
I
understand?
have gray hair as well.
Yeah, but you're not old yet, so don't worry about it.
Kind of. I'm in the way.
But you understand? So guys, and sometimes it's that little glitch that's interfering, and then once you realize it, you get that aha moment, and then everything starts to fall into place a little bit more clear. You understand? Guys, can I ask you a question? If I would ask you what's 2 plus 2, what's the answer?
4, I hope.
4.
22.
Wow, you guys don't even hesitate that it's 4 now, right? The first time you learned 2 plus 2, did everybody have an easy time to know that it was 4?
Yes.
Why is it so easy for you now to comprehend that that's equal to 4?
Experience.
Exactly, guys. Okay, so every time you learn something new, you got that hurdle to overcome, to grasp it, understand the concept, how to apply it. And then once you start really working with it and feeling comfortable with it, it's just the way 2 plus 2 became comfortable with you now after so many years of school. All this other stuff that you're learning in your career, it's going to become as comfortable. Understand? It's like I'm doing 2 plus 2 for the last 40 years with all my engineering. So for me, all this engineering is as easy as somebody asking, what's 2 plus 2? It's 4. So it's all going to come, guys. Don't be afraid. I mean, don't be patient. And as long as you're willing to understand it, it will click. and it will start falling into place. And and that's with anything that you've learned throughout your school. The more you've used it, the more you've applied it, the more you realize it, the more you understood it, the easier it is for you to to use it. So that applies to anything. Like, the first time they explain to you about graphs and they show you the slope of a line, wow, what is that, right? And then they try to explain to you how to calculate the slope of the line and what this means. And man, the first time they explained that, like, it was way over your head. Today, it's more understandable. It's like anything. The more you use it, the more you can relate to it, the easier it is for you to follow and be able to apply it to whatever else you need. You understand? So everything's like that, guys. So be patient. Just be willing to, force yourself to understand it. And once it understands, you'll remember it for the rest of your life. I can guarantee you that. There's a lot of things that I heard in school, okay? And then in my career, I saw something, and then I was really be able to totally relate to what the teacher or the professor was trying to say in school, because that's when I would say, that's my aha moment. Aha, finally got what he was saying. You understand? Let me give you a simple example, okay? First time I looked at open web steel joists, okay? I looked at open web steel joists like this being supported here on a beam, okay? And I looked at, and I asked myself, why is there so little steel here and why is there so much steel there? I just couldn't understand that whole concept. But then when you realize that here the only thing you have is shear, and here you have your bending moment, and you start understanding how the whole forces affect this member, you can start relating to why the thing was designed that way, and why here you only need the steel for one force, here you need the steel for another type of force, blah, blah, blah. And it all started to come together. But that, the first time I saw this, it was like I was questioning, why do they build like that? And then as you understand forces, and as you understand resistance and what it takes, what you need to resist here is only shear, and therefore all you need is enough steel to resist the shear. And here what you need is and then I understood that the further the cords were, well, the stronger the bending resistance was. And it didn't happen the first time. It slowly, and then as one piece fell in, everything started to fall together, guys. So it's like anything, okay? There's a lot of things that you've learned in this program that you just, you remembered it for the test, and you got it on the test, and you don't really understand it. And one day you're going to be on a job site and you're going to see it again, and all of a sudden you're going to probably see it from a different perspective, and it's all going to come together. Understand? It's like, it's everything's like that, So just remember, back when you learned 2 + 2, and the teacher said that's equal to 4, and you said to yourself, what? And that's exactly what's happening in many times, you understand? But eventually this 2 + 2 is equal to 4 will apply to everything that you've learned. So just, don't give up. That's all I can say. Sorry about that little.
Can I just show you my screen again? I'm just not sure.
Sure. Go ahead.
Right.
Go ahead. Yeah, go ahead.
Okay. Is this correct? Like, this is the top of the truss. It's like that's how it's supposed to look like?
As a matter of fact, what some people do, okay, what some people will do is, you see, can I draw on your thing? Okay. Okay. As a matter of fact, what some people will, let's just say that, okay, annotate, okay. What some people will do is, see here, where these two pieces are touching here, if this is where they would touch, okay, they wouldn't even bother doing that. They would just leave them like this.
Oh.
You understand? And then they would let the gusset plate do the work of holding them all together. You follow?
Okay.
Like, if you're asking me what is the best way to minimize any secondary effects, okay, that's what you should be asking me, okay? Okay, the best way to minimize any secondary effects in anything, okay, is this. Let me just erase this and I'll show you, if you're asking me the best way to draw this, okay? This is the centroid of this member here. You understand?
Yeah.
This is the centroid of this member here, okay? This is the centroid of that member there. This is the centroid of that member there. The best thing is all these lines intersect all in the same spot. All the centroids intersect at the same spot. That is the best, Rena.
Oh, okay, I get it.
That is the very best, but sometimes it's impossible. You understand? So if you're asking me what should be the best thing you should be aiming for, is where all these lines intersect at the same spot. That's the best.
Mm-hmm. Yeah.
Okay. So for example, so if you're asking me when I draw this, what should I try to do? I should try to make all those center lines always try to meet, intersect at the same spot. That's what I should try. And if I can't, well, I'll try to make at least two meet at the center. Like these two will meet there, you understand? And then I would place these so that they can get as close as possible to that center line, to that intersection.
Mm,
So
okay.
that is really, okay, and that's really like you know, so if you can do that, perfect. And if that's what you can do, and that's why when they place these members, like they don't worry about the mitering, they put them like this. They're more interested in making sure that the center line of that member and the center line of that member, understand, intersects the center line of that member. You know, that's, if you can achieve that, it's even better than worrying about mitering.
Okay.
You see?
Yes.
So that's what, you know what I mean? So like you're not looking at this, you're looking at really the effects, because it's really what happens is that when these things don't intersect, that causes eccentricity. You have secondary effects. Sometimes it's minimal, okay? Just to give you an appreciation, okay? Okay. You know open web steel joists, okay?
Yeah. Mm-hmm.
Okay. Well, the web members, okay? The web members like this, the ones that have this type of web member in the open web steel joist, okay, Rena? Okay. What happened was, okay, they were so well, I mean, they were designed to the bone. Okay, they were designed to the bone. In other words, no, I don't want to clear the drawing. I want to annotate. Okay, so in other words, this member here, okay, and this is believe it or not, this them. Okay, they were designed to the bone, and all of a sudden, there was one roof that had collapsed. Okay. Yeah, I wasn't involved in this, but this is something I read. Okay, and what they found was, okay, when the engineer designed the joist, what they found is that when you look at this member here and you look at that member there, where these two intersected, right out here, and when they looked at the bottom chord, well, if they completely excluded the eccentricity in their calculations, and that's what made the whole thing collapse. Because it was so, you know, it was calculated with no eccentricity and with the bare minimum, and because this was not coinciding with that, that's what made it. And now, of course, the code requires that when you're designing trusses, you have to account for the eccentricity if there's eccentricity in the chords with respect to the top, in the web members with respect to the top. So in other words, this would cause eccentricity. You better make sure that it does not have an effect on your final design. And that's why, guys, I keep telling you, put a little bit more, because all these secondary effects, if you design it to the bone, and if these secondary effects happen to spill your glass, it's going to fall. So don't try to design to the bone. If you can put some meat on your bone, put some meat on your bone. You understand? And believe it or not, now of course when they revise the code, when they revise the standard for steel structures, now you got to take that into account when you're designing the size of an open web steel joist. But could you imagine? And it's not that much, this distance here, but and that's what actually causes the thing to fail. Okay, and that's something that the guy overlooked, and that's why don't try to you know, make everything to the minimum. Put, if you have the room and if you can put some meat on the bone, put some meat on the bone. Feel like, you understand? So there you go. So this is good. But if you're asking me what's better, what I like to do is I like to draw the center line of all the trusses and then offset from those center lines and see how it looks. You understand?
Yeah, thank you.
Okay, so that would be the probably like the more precise way of doing it. But like, you know, but these things, like I said, if you make sure you put 3 extra nails in your gusset plates and not like if I end up with 21 nails and I see that I can put 3 more nails, I'll put 3 more nails. Like I told you guys, when they revamped the whole nailing thing, half the trusses that I've modified, not half, all the trusses that I modified, if I go according to the new requirements of nailing, I only got half the nails out there. And that to me is very scary, understand? But yet I followed the, you know, to the T. And then some, I added a few more, but so far so good, nothing happened. But I can tell you that when I saw the new way of calculating the nail requirements, with I was only allowed 1 shear plane, not 2. In theory, I had half the nails according to the new way of calculating the things. And even if something would happen, yes, they would say that, yes, at the time that's the way you did it, but they wouldn't exonerate me if something happens. It was up to me to decide whether or not that was sufficient. So. Okay, does anybody else have any questions?
Yes, sir, I have a question.
Go ahead.
About, I'm gonna share my screen again. 1 second. So because this one, it's giving me troubles. I don't know how to start this gusset plate here. Like from where do I offset? Like
Well,
because
it's
I
very
have
simple. Here, like very simple. Start, like, can I annotate? Okay. Yeah. Okay. Start here. Okay. And draw a line perpendicular to there. And then offset your end distance, and then offset your A distance, and then offset your end distance, and that's where your gusset plate is going to stop.
Okay.
You see, because this, like, in other words, if you want, you can start from here and draw a line perpendicular to there. It's up to you, Omar. You understand?
The thing is, so what about the nailing on here, like from here, like on this member? Do
Yeah.
I because I have, do I offset it? Like how exact do I offset it? Like I have, let's say 11 nails. Do I put like exactly the, let's say
You have 11 nails up there.
let's say
That means that you have 11 nails here.
No, they're, let me see, they're the same.
They should be the same.
They're the same.
Yeah, they are.
They have to be the same, because the only reason why you put 11 nails is because you have 11 nails there. Okay.
Okay.
So what you do here, for example, see where this member is in the middle here, right?
Yeah.
You need, okay. So now don't forget this is like, for example, okay. So, okay. So in other words, from there, you like that's the middle of that member there, right?
Yeah.
Okay. So put 30 on this side and put 30 on that side, millimeters. I don't know what it is in inches, right?
Okay. Yeah.
And then after that, 60 and 60, and go work your way that way until you have your 11 nails.
Just don't mind me asking, why 30? Do you put it's
because you need, because right now you need 60, right?
Isn't it 40 though?
I'm sorry.
The edge.
No, I'm sorry. Like what I'm saying is that you need 60 between your nails, right?
Yeah, exactly.
So I'm splitting that equally on both sides.
Okay. So
so this way I'll end up having 60 there, and then I have my 60, and then you understand?
Okay. Okay.
Or
so
because you know, like you're going to be putting the equal number of nails on that side as you will have on that side.
But my question is, do you put 11 on either side, or just 11?
11 total.
Okay. Total.
Because here you don't have a joint. The only time that you have to put the number of nails on one side, or do you have any joints in here, Omar?
No, it's only at the bottom. Okay. Yeah,
No,
I get it.
the joint is right there. You see, there's your joint right here. So that's why you need 11 there and 11 there.
Okay,
Okay.
I got it. Thank
Now
you.
you got it. Okay.
Thank
So do you understand why? How you asked me how would I do it here? I would start from here and understand. I better close this. Did I lose you guys? Because all of a sudden I saw my.
No, we're still
No,
here, sir.
so
Yeah.
Okay.
So,
Sorry.
sir, can I share my screen 2 seconds?
Yeah. Go ahead. That's what we're here for, Gina. Go ahead.
So, in this joint here,
Yeah.
all right, like for the gusset plate on this, like you're splitting it evenly, right, on both sides.
Well, what I'm doing is like, for example, this one you have to add the sum of these two have to go here. So, you know, like whatever number you have these two, this one has to have the sum of these two because this has to be able to resist these two forces.
Wait, so are you annotating?
Pardon?
Are you annotating?
No, I'm not annotating, but I will
Okay.
if you want. Hold on a second.
Yeah, I wasn't sure where you're pointing.
Yeah, let me annotate. Okay. So on this member here, I need to have the sum of this one and this one.
Okay, yeah.
Do you understand? So for hypothetically, I don't know how many, like he said he had 11 nails there. So I'm assuming you have 11 there and you have about 12 there, right?
I'm just looking at my paper.
I don't know. I'm just guessing.
I got 12 and 13 for the like 3
12
and
and
4.
13.
Yeah, exactly, sir. Exactly. I have exactly the same amount of nails.
11 and 12 or 12 or 13. Is that it?
I have 15 and 11 nails.
15 here and 11 there?
Yeah.
15.
I've
Okay.
got 12 and 14.
12 and 14. Well,
Yeah.
you're supposed to all have the same number of forces. We're all supposed to have the same number of the NR value is supposed to be exactly the same for everybody.
I got the same as Adriano.
Okay, so all I'm saying is that in theory we should all have the same number of nails.
And like you said, sir, it gave me the for my joint 5, let's say, it gave me 26 in total. It gave me the exact total I needed.
26, 11 and 14. Is that it?
Well, 15. Yeah, 11 and 15 for me.
So you got 26 and
Yeah.
you got 11 and 14. So, okay, so let's say there's 26 nails in here. Is that what you're saying?
Yeah.
Okay, so what you should do is like you can like so 26, like so it's up to you. Like for example, you can start like right down the middle and put them evenly on each side. Okay, or
Okay.
it's up to you. You understand? Like to me, it's easier. Like if I'm going to start down the middle, I can split half and half. You understand? And see where I end up. And then
Yeah,
see
makes
if
sense.
you understand.
You know, because I was putting 2 of them, so like I was getting that's why. Okay, makes sense now.
You see? So
Yeah.
that you know. So that like so therefore like so now do you want to like to me I'd rather try to split them evenly on each side of this line. So therefore instead
Yeah,
of
for
like
sure.
starting like right down the middle here and then maybe you know it's you know like it's just a question of it. Or you might start by having your first 3 nails here and then putting your 60 and then see if that works out. You understand?
Okay. Yeah. Thank you, sir.
Whatever works out, you know, you're welcome, but you understand whatever works out nicely. And I think that in theory, by the time you finish out here somewhere, and by the time you do this, and by the time you do that, I think in theory you should have enough space in here. I'm not sure. If not, then like you said, this is what might determine the actual size of the gusset plate. It's either the nails in here or there. It's one or the other, or they both might complement each other.
Okay.
I'm going to have to eventually draw them myself before the end of the semester. So to make sure that when I'm correcting to see who's right and who's wrong, you understand? So, but it shouldn't take me very long. Yeah. Okay, so that's good. I'm glad you guys are starting to feel more comfortable with it. That's what I mean. I'm glad you guys are feeling more comfortable with it. And like I said, this is the most tedious part of the project. Do you agree with me that's the most tedious part of the project? Or do you find it?
Sir, I have a question for you.
Go ahead, Sean.
What is the what's it called the strike about?
Oh, well, the strike. Well, well, first of all, the union's been negotiating for over a year with the government. Okay, And of course, with the pandemic, a lot of things were kind of like left in the air. And what's the strike about? Well, it's because the government is not sitting down and willing to negotiate the new contract with the teachers. They want to. There's a few issues that the union is trying to get across to the government. For example, you know the teachers that teach on continuing education, the evening courses.
Yeah.
Well, they're not getting the same remuneration as the teachers that are teaching day. Okay. And that's one of the things that the union is trying to get the government to cough up, that the person that comes in and teaches continuing education, he should get remunerated properly. That was one condition. There was another condition. Anyways, there's a couple of conditions. So basically, to force the government to take the negotiations a little bit more seriously so that they can, meet the demands that the union is presenting to the government, they had a strike vote a week ago. Okay, this is not just Dawson, this is across the province. You understand? This is all the CEGEPs. And all the CEGEPs voted in favor of, all the CEGEPs had received, the mandate from each individual school that yes, they were in accordance going on strike. I think Dawson, there was for the people that voted, 74% or 76% of the teachers said yes to the strike. And therefore they got, once the strike vote is in, that means the union has, is given the mandate by the teachers to go out there and now, tell the government, well, we either start, sitting and negotiating with us in good faith and see if we can come to an agreement, or if you don't, we're just going to start striking. And that's what they're doing right now. So they started with a 2-day strike, which is next week, starting at Tuesday at 12 o'clock till Thursday, 12 o'clock. And then after that, I don't know what's going to happen, Sam, because after that, it's going to be the end of the semester. So the union is trying to make sure that they can start, they have more leverage when the teachers are in school than so.
Of course.
So
and my second question relating to this is, do you know when the wood project is due now, since the dates are being delayed?
Well, so I don't know what's going to happen in terms of the school, or is the school going to be extending the school year because of the strike? That look, Sean, if the school extends the school year by 2 days, then everything gets extended by 2 days. You understand?
Oh, okay.
But if they don't, I wouldn't count on that, because if the school decides not to extend the school year by 2 days, you understand?
Sounds good.
But they might, okay, they might extend it, but don't forget, they're going to be extending the Tuesday, they're going to be extending only the classes that were affected by the strike. So our class hasn't been affected by the strike. So in theory, like, they won't extend our class. Understand?
Okay.
So our class is Thursday afternoon, our class is Monday morning. Those days have not been affected. So they're only going to be extending the Tuesday morning, the Tuesday afternoon classes, the Wednesday classes, and the Thursday morning classes. You understand?
I understand. Okay, perfect. And I have a third question.
Yeah.
Theoretically, if one student did not want to do the drawing for wood because it was too much of a hassle or too long, how much would they get if they just submitted all the work beside all the drawings?
Half the mark.
Half the marks? So 50% and not 60?
Yeah, you get 50%. Yeah.
Oh, that sucks.
Oh, big time. not for me, because it'd be so much easier just to give you 50.
Is that one student you, Sean?
No. I was asking for a friend.
You're asking for a friend. I'm glad you're. So Sean, tell your friend that if he hands in just the design brief and not the calculations, well, he did half the project.
Harvell, you hear this?
Thank you, Sean. Thank you for asking for me.
Harvell, you were gonna take a risk that you were gonna get half the marks for your project.
Sir, Sean, don't pay attention to Sean.
No, Harvell, like, listen, guys, I don't like, if you look, I'm not doing this hypothetically, okay? If you look at the amount of time it will take you to do the drawings, the amount of time it would take you to do the calculations, I think it would come out to be almost kif.
No worries, sir. I'm almost done. Don't worry.
No, Harvell, but you understand why I say half?
Yeah, for sure.
Because I think in terms of time, if I calculate the number of hours it takes you to do a drawing, the number of hours it would take you to do the calculations, I think as a matter of fact, maybe I should even give some more to the drawings than to the calculations. Understand? So
That's true. That's 100% true.
see, so
Right.
that's why, like, and I say half to give you a little more of a chance to pass the project, because I know you guys are going to be doing the calculations as we're going along the semester. But I should, in theory, I should maybe make it 60-40. I don't know. You understand?
Okay, Signore di Cesare.
Yes.
Yes, I just wanted to say that sono l'assassino di insetti.
I didn't hear you. Sorry.
I want to say sono l'assassino di insetti.
Sono, I'm what?
Sono l'assassino di insetti.
You're a bug killer.
Damn right.
Oh, so am I glad we're doing this virtually? How's that?
Yeah, sounds good.
Sounds good. So
Okay.
well, Sean, like, I know you're going to be a bug killer, but I hope you're going to, get your deck, right? You're still planning to finish the program, right?
Oh, of course. I'm not planning on dropping out so close to the end.
Exactly. It'd be a shame because you never know. Like, this is going to be in your back pocket for the rest of your life. So,
Exactly. Yep.
So I hope, I was going to tell you, please don't, like, you're almost at the, you're almost at the goal line, and you might as well just cross the goal line, right?
Yeah.
Yeah. So that's good.
Sir, quick question.
Yep.
For the exam, you might have said this before, I didn't hear. For the Woods exam, there's going to be one problem on nailing and one on formwork.
Yeah, and I expect you to nail both questions. How's that?
I like that.
Yes, there's going to be one on nailing and one on formwork, but I expect you to nail both questions. Guys, look, you've been doing very well, so just keep doing what you were doing. I'm so far, guys, no complaints, you guys. As far as the results goes, you seem to, have a handle on things, and I'm not going to try to trick you on the last exam so I can all see you next year, because I won't see you next year. I'm going to be on leave next year. So anybody that fills a course, they'll have the pleasure of doing it with somebody else. You understand? But I don't see, like, if you guys are still, like, applying yourselves as much as you did throughout the semester, I really don't see an issue. You understand?
Sir, do you know who was teaching the course once you retire?
When I'm not there in the winter time, if I'm not mistaken, I think Jade teaches the steel and Steve Hinton teaches the wood.
Oh, okay.
If I'm not mistaken, if I remember, but so you guys were fortunate, because I was supposed to be on, well, fortunate or misfortunate to get stuck with me, but I was supposed to be on leave this semester, and because of the COVID, I decided to stay.
So you said that correctly. We're
Very
fortunate.
So
Very lucky.
So that's and now that I'm sort of like, anyways, I'm thinking of, I don't even know, like right now I hit 65 this year, and I mean, I enjoy teaching, guys. Don't get me wrong.
Chandani, sir, Chandani.
Yeah, thank you. That would be nice. That would be nice. Go to school in a walker, right? But anyways, look, it's. I mean, I hope you guys. All I'm saying, I hope you guys, learn something that you can, be of use. Like, you can be doing projects at home, and this can be useful, or you can do this as a career, whatever you want to do. It's up to you guys, but I can tell you that I'm sure you got a better appreciation of structures right now than you did 2 years ago, right?
Yep.
Yeah. So,
Sir,
yes.
a couple classes ago, you mentioned a document that you would try and find that has like all the snow loads of every town in Quebec. I don't know if you found it, or but I'd be still interested in receiving that document.
Oh, okay. Hold on a second. I'm going to hold on a second. Can you bear with me for 2 seconds? Okay. I'm gonna hold on a second. Like, I'm glad you brought it up. Yeah, I did mention that, right? And okay, hold on. I'm gonna see if. Okay, so let me just. So just to make sure we're on the same page, can you just give me a second? See, I don't know why this like, you know, I have to log into Dawson to get to the Omni, and then from the Omni I go to the Zoom meeting, and then when it sends me the Zoom meeting, it quits the the Omnibox on me. I don't know. Okay. Now, which class did I say this in? Was it in the steel or the wood? Do you guys remember? Hello?
No,
Well, do you want me to send it through the steel class, or do you want me to send it through the wood class?
it doesn't matter.
Well, I guess it doesn't.
Well, it
matter.
does, because there's more people in steel than there in wood. You understand?
Oh,
I mean,
well, might as well get it to everybody then.
Well, that's what I'm saying. So in other words, like, what I'm trying to ask you is that, okay? What I'm trying to ask you is, so if you go, hold on a second, distribute a document. What do you want me to call it? Quebec. I'm going to call it Quebec. Quebec climatic. I can't even spell climatic. Quebec. Okay. I'm going to put Quebec values. Okay. I'll send it through. I'll put it underneath the labs. Okay. And I'm going to, so it's, if you go to choose a file, just so that I don't, desktop, upload. Okay, so if you go to your Leah, it should be under the lab section of the documents, guys. Okay. I don't know if, let me just, yeah, I have it under Quebec values. Okay. So if you guys want to just go check to see if you received it.
Not yet.
It's not there yet, no? In other words, I put Quebec values and I categorize it under labs in the steel.
It's here.
It's there?
Yes, sir.
Okay, so if you open it, you'll see you'll have, like, it's much more elaborate than what you have in a National Building Code. It has a lot more towns, a lot more cities and stuff, you understand? And if guys, SQL Wall, if you go to their website, you might even get an updated one of this one, you understand? It's called SQL Wall, and I think they provide this through their website. But I think this one's 1990. I don't remember. Did anybody see the date on these ones?
What you sent is like from July 14, 2010.
Yeah, that's what it says.
2010? Okay. Yeah, and there you go. See, that's where I got it from. You see SQL Bowl? You understand? So if you go to SQL Bowl, you might even get, if for whatever reason they updated this, you can get it from SQL Bowl. So there's your snow load, there's your wind pressures, and of course, you understand? Which is very nice, and it's got a lot more towns than you can find in a National Building Code. Is that okay, guys? There you go. Center, shallow, yeah. And this is good to have, you know. Unfortunately, it goes by region. So if you don't know what region your town is in, but there you go. So thank you for reminding me. If that's okay with you. Okay.
Thank you, sir.
Oh, you're welcome. Like I said, that's where I got it, and I thought it was very practical to have, especially because, you know, I can tell you one thing. I can tell you one thing, that what a lot of people do, and it's very, very wrong. Hold on a second. I want to close something. I'll show you what a lot of engineers do, or a lot of, hold on. Okay, so I'll give you an example. This is a file that I was involved in, okay? They were designing something here, okay? They were designing something here in this region here. And the city of Joliet was here. This was Joliet. And I think Saint Agathe was over here, Saint Agathe. Okay, so what the engineer did is he went to get the values from Joliet, he went to get the values from Saint Agathe, and he says, well, it's about halfway. You understand? It's about halfway across. So he took the average of what he found in Joliet and what he found in Saint Agathe, and that's what he took as his snow loads, right? Well, this is in a mountainous region, and the snow loads were almost twice what he assumed they were. But if he would have had this little chart, he would have had the right values right away, because that in that chart, that town was already there. Understand? So don't interpolate the climatic information, because when there's mountains, it affects. I mean, guys, just look at Montreal. You look at Outremont, and the snow load in Outremont is 2.8, and then you go look at Saint-Anne-de-Bellevue is down to 2.3. So even within Montreal, look at the difference in the snow loads. Okay, so don't ever interpolate the climatic information National Building Code. Try to find what it is. And what I like about that one chart, it has a lot more cities than you'll find in the National Building Code. So guys, I enjoyed this lab. I'm glad you guys had a lot of questions and made my time a little bit more interesting. And does anybody have anything else to say, or do you guys want to call it a day?
Sir?
Yes.
Question about steel.
Steel, okay.
So it's basically it's about the girder connection with the column.
Okay, the double angle connection with the column, yes.
Yeah. So my question is, can, let's say, a column, because the column width that the column flange width that I chose, it's 200 by 31, and the width I checked on the W shapes, it's 131 millimeters.
Yeah, okay.
And the Gerber girder beam, its width is 179. So clearly it's overlapping. So is it okay when it's overlapping, or it's no good?
It's not overlapping.
Well, one is 134 and the other one's 179.
Yeah, but look, it's not overlapping, because what you're saying is this. Okay, let me just show you what you're saying, and I'll show you that you're not overlapping. Okay.
Okay.
So in plan view, here's my column, like this. Okay.
Yeah.
And you're saying that this here is 134.
Yeah, exactly.
Here's my Gerber girder, and you're saying that this is
179. Yeah.
179. So
Yeah.
what does this have to do with this?
Oh, okay. All right. Okay. So
what you have to worry about is making sure that the angles in here can fit on the 134. That's what you should worry about.
Okay.
You understand? So
yeah,
it doesn't overlap. As a matter of fact, you're supposed to leave a 10 millimeter gap between the two.
Okay. Yeah.
You understand? So like, don't worry about that. Like that's like, it's not going to overlap, because they're completely, they're not even touching.
Okay. Yeah, that's right. Oh, all right. Okay.
So what you have to worry about is making sure that when you put your angles here, don't use a 76 by 76, because I take 76 times 2, that's 152, right? And you only have 134. So that's not going to work.
Okay.
Do you understand what I'm saying?
Yeah. So
you should worry about the angles here. Here you're going to use 76 or whatever you want. That's okay, but when you're going to be welding it to the column here, you're going to have to make sure that you might want to use 52.
Something smaller, right? Okay.
That's what you should worry about. You understand?
Yeah. Okay. So I have to tweak my design a little bit, because I picked 2L 76 by 76. So that's
but see, that won't work, and I would mark that wrong. You understand?
Okay. Yeah. Okay.
But this, like, it is what it is. It will not create any constraints, or that you need to do your connection.
Okay.
This will create a constraint, and that's why you have to worry about those two angles there. You understand?
Okay.
So I'm pretty sure, like, if we take 152 by 52, that's 104.
104, yeah.
And I think the web here cannot be more than 14. I said it can't be more than 14 millimeters. Am I correct?
I have it open in front of me. Let me check right now.
I'm sure that it won't be more than 14 millimeters. I'm just guessing at this point. It can't be more than 14 millimeters.
Triangle, double shape. That's the W610 by 92. Let me look. 100, 610, 92, all the way down. Okay, let me zoom out a bit. Okay. So that's the what the
W, the small W, the web.
the W, that is 10.9.
Exactly. So 11 millimeters, add 2 more millimeters. Okay.
That's the 13.
That's 13 plus 104. That's 117.
17, so it's good. It works.
No. You still have to worry about the size of your welds now. For example, if you, because you haven't added the welds yet, you understand?
Okay.
So let's say you're using 6 millimeters weld. That's
times two welds. Okay. That's 139.
Well, 129, right?
29, sorry.
So if you don't go over 6 millimeter welds, it might work. You understand?
Okay. But my welds, I think they're, look correctly. Okay, so basically for my design, I have to make it smaller because it doesn't work. Okay, thank you, sir.
No, all I'm saying is that this is what that's what this does. It kind of confines this, and that's if you want to use a standard 52. You understand? Like, because there's nothing to stop you from telling the guy cut it down to 45. You understand?
Okay, right. Okay.
It's just that you want to avoid having to pay an extra cut. You understand? So
sure. I also
because like I said in class, like if you look at the table, if you remember, I told you the real strength comes from this part of the weld. You understand? And at one point, you see that no matter what the size of the angles, you have the same VR value. You understand?
Okay.
So as these things get shorter, they get a little bit stronger. But you understand?
Yes.
So
and I'm not constricted to choose equal angles.
No.
I can pick unequal angles.
You can take unequal angles, and and then even if you take unequal angles, and for whatever reason, because what you have to worry about, okay, even if you take unequal angles and you can't find one that fits in your geometry, you can always tell the guy to cut it.
Okay. All right.
You follow what I'm saying? It's just if you want to avoid having to cut them, you're better off be a little bit cheaper, and remember, if you take unequal angles and you're cutting it, right? So now you don't have that fillet anymore. So you don't have to worry about, so by cutting it, you're getting rid of that fillet. So that now you got this full height here to be able to put your weld if you want to.
Okay. All right. I understand.
So, okay.
Yeah, that's clarifying things.
So like, but you understand why in plan view, the width of the flange of the W610 by 92 has nothing to do with the column?
Now I understand. Yeah.
You see that? Okay.
Yes, sir.
Okay, good.
All right, good. Thank you, sir.
You're welcome. That was a good question. Okay, so guys, there's nothing else. We'll see you Monday morning. I will have the test ready Monday morning and off by 8 o'clock. So, and in the meantime, stay safe. Oh, do you know if your exams have been canceled next week because of the strike?
Yeah, 2 of them.
Project management.
Well, they don't know yet.
Yeah, well, it's
he just said the
strike is confirmed. So it's billing systems and project management.
No, she said she's gonna send us a mail. She already know it's confirmed. It's confirmed. Like
so it's confirmed.
So that means it is canceled if Joe just said it's confirmed.
Yeah.
Well, I'm waiting for the Mayo, bro. If she doesn't send us a
Keep
Mayo,
waiting.
Keep waiting.
Okay.
Okay, you're waiting for the official confirmation.
Yeah, from government.
Well, I think that according to what I read, I think that in theory, if my class happened to fall within that strike period, I have no choice but to cancel. You understand? So I'm not sure. Like,
it's actually better this way because the initial planning for the exams, we had 2 exams in the same day. This way, we have 1 exam a day, so it's not as bad.
I understand. So it worked out to your advantage, you guys.
Yeah.
That was good. So, okay, so guys, I'm sure you'll all be ready for Monday morning for me. So we'll talk to you guys then. And in the meantime, keep working. Don't give up. There's only 2 more weeks to go.
Have a good weekend, sir.
Take care.
You two guys, take care. Bye bye.
Thank you, sir.
Thank you, sir.
Bye, sir.
Bye bye, guys. Thanks.